My name is Knüppel. I'm from Airbus Operations. We are located in Bremen, so Germany. Airbus is a bigger company, one of the biggest companies selling aircraft and manufacturing aircraft, and we are involved in developing our own systems together with suppliers, and we are also very active in connecting all the different nodes into a common aircraft network. So I would like to talk about CAN-FD in aviation. We are actually undergoing an update of our networks, and so let's talk about that. We started actually in 2006 with the activities and established our standard ARINC 825 in 2008. It was based on ISO 11898 and was the basis for interoperability, and was adapted to the specifics of aviation, because we found out that CAN bus itself worked well in the industry environment, but not so much for in the aircraft environment. So we continued our activities. We made an update, a so-called supplement to the ARINC standard in 2010, another one in 2012, and so forth. We are actually working on supplement 4 because there's CAN-FD on our list now. Just something about the working group. I'm one of the members. Another member is sitting there, Jim Meir from Microflight. You just heard him before asking some questions. So ARINC is the head of that working group, and different companies are involved in that activity. So first there's Airbus and Boeing, the two big airframers. And then there's, for example, Excalibur Systems, which do produce test equipment. And there's Panasonic, which are working on in-flight entertainment and other things, so electronics. There's also GE Aviation. And on the left side, you see in the dark box, designed to fly Michael Stock. So we just heard about CAN Aerospace already. He is mostly the inventor of that CAN Aerospace standard. He standardized the way how the nodes communicate, and he was part of the ARINC committee as well. Meanwhile, he is so busy because the idea is so successful. His equipment is now sold and incorporated in small airplanes, maybe the Rotax engines for very small airplanes, private ones, and he has an engine controller and so on, interconnects the different ECUs and other equipment. So that's really a success story for him. But he did contribute a lot to the standard. What are we talking? The industry background is that on commercial aircraft, on the other side, we have about 80 systems per aircraft. That's a mean value, 80 systems per aircraft. And they have in mean 3 bus segments and 25 nodes per segment. So quite a lot of CAN bus on aircraft already. And so we use the ARINC 825 standard for CAN bus systems in aviation, so that's generally understood between Airbus and Boeing, and for other manufacturers as well. And the environment is we have to cope with EMI lightning protection. We have cable connectors, cable length issues. We have to have protocols, and we want to provide guidance for the designer to be able to work with all of that. And the aircraft life cycle is about 30 years. So you have to keep up running your systems for 30 years. And so you can imagine that obsolescence is a strong factor for us. And we are asking for, or questioning us, what is an update strategy for CAN nodes, and even more when we hear that maybe CAN will become somehow obsolete and will be replaced by CAN FD. So we have to think about that situation. And this means mostly redesign, because there's no pin compatibility in the equipment and so on, so we have to think about that situation. And what we do in that group is we try to establish a link between the chip industry, the automotive industry, which is a real big market, and our small aviation industry. We have a few nodes compared to the automotive industry, but I mean the market for aviation, for selling aircraft, is quite big and important. So let's talk about what we have been here last year already. So the situation at that point was we had the update on the ISO spec for CAN FD. Some chip manufacturers plan to move into CAN FD. FPGAs were available for development and verification. There were transceivers available, and the FD implementation in cars are supported, or were at that time supported already by Volkswagen, Porsche, Mercedes, General Motors, Toyota, Hyundai, and so on. And in the aviation industry, it cleared out that Airbus was going to support, Boeing was going to support, and many of the suppliers were going to support the new standard. So what we did last year in December, we achieved to have a Plugfest in Munich, near Munich, in Berg. And we have another Plugfest planned for April 2017, so this year in April in Santa Rosa in California. And this will be discussed later in the presentation. And then for 2018, we hopefully will have the Supplement 4 ready, including CAN FD. So this is the cover sheet of the standard, and we plan to incorporate various items into the standard. Most important is CAN FD, and we will talk about timing and bandwidth management and so on. So various topics we have to cover. Actually, the working group is very busy with the following points. We have a discussion on the sample point, and there has been a calculation proposal, and we also had a discussion with Dr. Mutter from Bosch. So we had some feedback that our calculation was not accurate in some points, and we need to update, so we are going to do that. And also we try to make things simpler for our suppliers. So we try to standardize in so-called the communication with so-called XML schema. We already have a proposal for that, and the proposal is under evaluation within that group. There was also a proposal for management information base, and this also is under evaluation, so you are welcome to contribute as well, to review these documents and give your comments to that, and we are asking for that. So if you think that this would help us or would be of interest for you, you're invited to join the group. And to prove our concepts, we set up an integration test rig, just a small one to start. And we want to integrate more nodes, because we found out that integration is really an important factor. And what we have on our list as well is the topic security. So we have detected that last year there was a discussion with the authorities on the CRC values, and there were some papers issued by the FAA questioning the security, the security of CAN, and therefore there was an answer already by updating the ISO spec, but to be prepared in that case to provide more evidence, we are planning to set up a security test rig as well. I'll come back to that later. So please give your feedback if you want to contribute or participate. How does it look in detail? This is actually the setup that was proposed by our colleagues from Boeing. They have set up with, let's say, implementing parts of the aircraft which are flight essential, and setting this up with CAN buses. In the middle, you see the gray fields. Here in that section, you see the systems and divided into channels. And you can see on the left side the computers which, let's say, work with software on the communication. And on the lower part here, there's a flight simulator, very simple one, just to demonstrate that the flight critical parameters are correct. And so you can see the airplane flying. So I think it's a good approach for a first setup. It was a good demonstration what we had in December. You have been witnessing, so thank you for that. So this was part of the configuration of the Plugfest. Various cables. And the interesting thing is that different suppliers were involved in that, and we had, let's say, we got this to work within half a day. So this was really a success. And as I said, there will be another Plugfest in Santa Rosa in USA on April 18th. So you're welcome to join us. We will have other equipment by that opportunity, and just to show you, this is one of the boxes that had been integrated as well during the Plugfest in Munich. This is a box from Stock Flight Systems, intended for general aviation. So in general, this protocol at that time worked well together with our nodes. The basic principle of ARINC 825 is service-based communication, and so the protocols of ARINC 825 and CAN Aerospace are very similar, and Michael Stock, in this case, made an implementation of ARINC 825-2 work for us, and this box actually is flight-worthy, so it's it's flying on general aviation aircraft. Some words again on the security test rig. The paper I was talking about was the Dr. Koopman paper. He detected some CRC issues of legacy CAN, and for some input vectors, CAN did not fulfill the Hamming distance of 6, and CRC was corrected in the CAN-FD specification. And what McGill University and Esterline, these two, one company and one university in Montreal, are going to investigate is they will set up vulnerability checks to verify that this is true, and other checks. They will implement other security checks as well. What they think that which is necessary to verify. So what can we say as a conclusion? The ARINC standard supplement 4 will support CAN and CAN-FD. And aviation systems will use CAN and CAN-FD in the future. So there's not a total replacement by Ethernet. So we can see this on the horizon somewhere that Ethernet will become more important, but it is only a discussion so far, and the backbone is Ethernet AFDX. So the real security network, safety network network behind. So the backbone is AFDX, and the systems do their operation with CAN, or in the future with CAN-FD. That's the target for Airbus. And Plugfest helped to integrate CAN or CAN-FD nodes and helped to find out about issues and problems, configuration problems, parameter settings, and so on. So we found out that this is really an important factor. And CAN-FD, the use of it will avoid obsolescence problems in the future, which will come for sure when we only stick to CAN. ARINC 825 will guide suppliers, designers, to make the right decisions for the implementation of their systems. Aviation is a growing market for CAN-FD, so in the long haul we will replace the CAN nodes with CAN-FD nodes. So every time there will be a new system development, this will use CAN-FD. And this concerns general aviation and also, I mean, the most important is commercial aviation for me, but this will also be in general aviation, so stock flight systems will take care of that as well. And what we can say is that there are several steps still to go. Okay.
Okay, thank you, Ralph. Maybe there are questions. I see already one. One moment, please.
Automotive from Bosch. My first question would be, during your Plugfest, what did you test? Did you test the physical layer, so cable lengths, specific connectors, or did you test some sample point positionings and robustness, or did you test higher layer protocols? So what was the focus?
Okay, you can see here the setup, and the configuration was this. So we set up this, I would say, more or less complicated network. So different systems were involved, and this was an end-to-end test. We sent out test data, so flight data, and received it here on the simulator here. And what you could see was that the aircraft was flying, was maneuvering like this. And so this was enough witness for us to say, okay, the data which comes from the boxes, from the simulation, went through the network, was assembled, disassembled, and put into the flight simulator. So it was not targeted on physical layer, it was an end-to-end test.
And you talked about, or you said that CAN-FD will be introduced in aircrafts.
Yeah.
And there's some work to do.
Yeah.
And what do you think, when will we see, or when can we fly with the first airplane with CAN-FD?
Good question.
Roughly, so.
Yeah, good question. I cannot speak for my colleagues from Boeing, but as they have the newest program in aviation available, so maybe they have something already ready for flight. I don't know. I cannot tell you. For Airbus, we are, let's say, roughly planning a new plane, but this will last a little longer. So we are busy with delivering aircraft, not so much with development, but there are research activities going on, and for sure you will, I mean, CAN-FD will be part of these research activities as well. So flying an aircraft, I would say something 2025.
Okay. And what, last thing, the bit rates you focus? So what are you targeting?
For CAN-FD, yeah, that depends on the application. The more robust the network, the better it is. So we try to be as low as possible with the data rates. A few years ago, I already presented the smoke detection system of the A318 at that time, which used 83.3 kilobits, and that is sufficient for that application. You have a poll rate of 2 seconds, and so that's if you have that bus speed, it's sufficient. I know from other applications they use up to 1 megabit, for example, in the cockpit for the cockpit display system to transfer data from one computer to the other. So the cable length is really short, but still 1 megabit. And I can think of other applications in the cabin, for example, and actually I know that for seats, they will use, 2 weeks ago I was with a supplier who said they will use seats, in their seats, two CAN buses, one slow speed CAN bus and a high speed CAN bus, whatever that means. So they will use it, the high speed for in-flight entertainment and other applications for transferring data onto your phone and so on to make, I mean, it's in business class, so that it's, and this seat is currently under development. So that will last maybe 2 years, and then you will have CAN bus in seats as well. So for the cabin applications, I think that this will go on. And in especially one feature is of interest, that's the data loading, because then you have high volume of data which needs to be transferred to many boxes in the aircraft. And that's a clear field for CAN-FD.
Okay, thank you, Leif. I think you can continue discussions and questions on the...
Yeah, I'm looking into hungry eyes.